The third method for solving system of equations is using the elimination method. The elimination method is a method we're going to use when we see that both of the equations are given in standard form. If you remember, standard form looks like something x plus or minus something y equals c. Okay, so we would call it ax plus by equals c. And when we talked about this back in chapter 5, we said a had to be a positive value. In this case, we're not going to worry about a being a positive value, but you'll notice that we start with the x term, then we go to the y term, and then we have a c term. If the x and the y are in backwards order, this method will still work, but it's kind of the way that we look for, should I use the elimination method? So there are kind of 3 different levels of doing elimination method. This we're going to start with the easiest level. On your test, you're going to get some level 1 and some level 2. Level 3 is going to exceed what we're going to do on the test, but it's something that's good to know. All right, so level 1 is when we have the 2 terms that are the same but opposites. So if we're looking through here, we've got our x plus 2y equals 9. And on the bottom we have 3x minus 2y equals 3. So notice how these two y's are the same term, but the sign in front are opposites. So if I were to put them together, I would make a 0 pair. In other words, they would add up to nothing. So let's add both equations. So when we find that we have opposite equal terms, we can eliminate them. That's why it's called the elimination method. By adding them together, they make 0, or in other words, I just crossed them out. So what we did is we added the top equation part and the bottom equation part. We're going to do that with the whole equation, because what you do to one thing, you need to do to everything. So since we added these 2 terms together, we're going to add these terms together and these terms together. Make sure that you look at the sign in front. So these are both positive. X plus 3x is 4x, and I'm just going to put it over here. 4x equals 9 plus 3 is 12. I'm going to solve for x, so I'm going to divide by 4 on both sides. X equals 3. All right. Remember, all system of equations don't have just one number answer, but they're given in an ordered pair. So since x equals 3, that's our first value. Remember, an ordered pair says x first, then y. So since we solved for x, we're putting the 3 in the x position. Now I have to solve for y. We're going to do that the same way we did in the other methods. We're going to take this 3 and we're going to plug it in either one of the equations for the x. So I'm going to plug it in right there. Instead of x, I'm going to put a 3. 3 plus 2y equals 9. And good thing we practiced 2-step equations ever since 7th grade. So we're going to solve this 2-step equation by subtracting 3 first. And then we have 2y is equal to 9 minus 3, which is 6. Divide by 2, and y equals 3. X equaled 3, y equals 3. And our solution is 3, 3. The ordered pair 3, 3. Let's do another one like that. This one has no coefficients, and that's okay. What we're going to do is we see that we have x and x. We also see y and y. But notice that the x's are the same sign and the y's are different. So we're going to eliminate those y's again. We're going to put the 2 x's together. X plus x is 2x equals 8 plus negative 2, a positive 6. Divide both sides by 2, and x equals 3. Again, are we done? Nope, we know one of our 2 terms. So the first term is 3 again. So now I'm going to take this 3 and I'm going to plug it into one of these equations. We'll plug it in here. So we've got 3 plus y equals 8. Solve for y by subtracting 3 from both sides, and y equals 5. So we've got the ordered pair 3, 5 as our solution. Okay, making it just a little bit harder here. What if I don't have any equal opposite terms? In this case, I have 2 terms that are close. They're equal terms, but they're not opposite terms. So what I can do is I can make them opposites, or I can subtract the whole thing. So I think it's just easier, since the next step we're going to do is by multiplying by something to make them equal. So I like to stick to that, not having too many rules, and just say we can multiply everything by its opposite. So first of all, I'm looking and I see 3x and 3x, but the 5y and the 2y, they don't match. So they're not really close to being a match, but the 3x and the 3x are so close, just one needs to be negative. So in order to make one of them negative, let's say we're going to make this top one negative, okay? In math, a couple things could have happened. I could have multiplied it times -1, or I could have divided it by -1. A few other things could have happened, but those are the only things we want to do, is multiply or divide. So let's go ahead and say we multiplied by -1, and I'm going to do that to every single term here. So I'm taking all of this and I'm timesing it by -1. Well, the easier thing to think of is if I make one of them negative, I'm making them all their opposite. I'm not making them all negative. I'm making them their opposite. So the opposite of 5y is -5y. And the opposite of -2, that changes to a +2. See how I made it its opposite? And I didn't just change it to negative. Okay, now that I have opposite equal values, I can cross these ones out. I've eliminated them. Now I'm going to put these together. Remember that 5 is now a -5, and a -2 makes a -7y. And then when I add these two together, I get -14. Divide both sides by -7, and y equals 2. Okay, this time I solved my y term first, so I'm going to put that there. And now I need to solve for x. I'm going to do the same thing I did when I was solving for y. I'm going to plug the y value this time in for one of the y values up above. It doesn't matter which one. I'm going to go ahead and use the bottom one this time, just because I changed so much on the top, it'll make it a little bit more clear to me. So I'm going to go 3x minus 2 times 2. A lot of times I'll do that multiplication part in my head, and then -16. Okay, so 3x minus 4 equals -16. Now in this case, it doesn't matter if you took -2 times 2, that would get us -4, right? Which is a -4, or 2 times 2 and then put the negative in front. That also works in this case. Okay, so we're going to solve this two-step equation. I'm going to add 4 first. I'm left with 3x and -12. Divide by 3, and x equals -4. All right, so my first part of my ordered pair is -4. My second part is 2. Now, just like when we did the graphing method, these are all going to be found in the graph as two lines that would cross at one point, right? I'm going to tell you about what it will look like if they were to be parallel lines or the same line after I do a little bit more examples. So let's keep going on. Here again, we have the same, so matching terms. I have a plus y here. Now my x and my 2x, they don't match. Okay, we could make them match, but that's what I'm going to show you in the next one. It's just one more extra step. So let's go ahead and make all of these. We'll do the top again, make them all their opposites. So the opposite of positive x is negative x. The opposite of positive y is negative y. And the opposite of positive 5 is -5. Now I can add these terms together. Negative x plus 2x is just x. Y, negative y and y cancel each other out. They're eliminated. And -5 plus 4 is -1. So x is -1. My y, then, I'm going to plug my -1 in. I'll do it to the bottom one again just so that things aren't so confusing. So I'm going to do this in my head. I know it's 2 times x, and if x is -1, 2 times -1 is -2. See how I just multiplied that in my head before I wrote it down? And then plus y equals 4. So I'm going to add 2 to both sides, and y equals 6. Okay, And my solution is -1, 6. All right, level 3 is where you don't have any terms that match at all. So they're not the same in any way. So now I need to look at these and I need to say, how could I make equal and opposite terms? Well, I could take this 2 and I could make it look like that 4, right? I could multiply it by 2. If I did that, I would multiply everything times 2. And since my goal is to have opposite terms, I'd really want it to be a -4. So I'd want to multiply it by a -2. So that's option 1. But I also see that there's kind of an easy option here. I could take my 3, and right now it's a -3, so I'd want it to be a positive. So I'd take it times -2. So this could multiply times -2 to be the opposite of -6. Okay? It doesn't matter which one you do. Either way is going to work out. So kind of whichever one you see first or whichever one looks the easiest math. And to be honest, neither one is really that difficult of math. So I'm going to go ahead and do the first thing I said. I'm going to multiply the bottom equation by -2. So when I multiply this whole thing times -2, and how did I choose -2 is that's what I needed to multiply this times to get this number up here. So I'm gonna rewrite this. I'm going to say, okay, I've got my -4x, I multiplied times -2, and -6 times -2 is positive 12y equals -8 times -2 is positive 16. Now I'm going to rewrite this top one just below it just so that they're lined up. So I've got 4x minus 3y equals 11. All right. So now I'm going to eliminate these terms. These two together create 9y. And these two together make 27. Okay, divide both sides by 9. And y equals 3. I'm almost done. My y value is 3. I need to figure out my x value. So let's go ahead and plug this 3 in. In either equation, we'll plug it in here for the y. So 3 times 3 would go here. So let me rewrite that. 4x minus 3 times 3, which is 9. So minus 9 equals 11. Add 9 to both sides. And I get 4x is equal to 20. Divide by 4. I'm running into my stuff here. And x equals 5. Hopefully you could follow that down. I ran into my number, but 20 divided by 4 is how I get the 5. Okay, let's do one more like that. All right, for this one, I think there's a more obvious answer to what we should do because I can see that 2 can multiply to be 8, but 3 cannot multiply to be -5. So I want to go with the first one because it's easier. Now, if you only had options like this one, you would have to find a number that they, like the least common multiple, right? The number that they both multiply to, but you want to try and keep the numbers as small as you can. So I could multiply this one times 3 and this one times 5, and that would give me a 15 on the top and a -15 on the bottom, which would be perfect. But since I have that first term where I only have to multiply one of them out, that's the one I'm going to go with. All right, so I want to make this 2 into a -8. So to make it into a -8, I'm going to multiply it times -4. I'm going to do that to all of the terms in the equation. I'm going to leave this one and write my new one down below it so that they're on top of each other. So 2 times -4 is -8x. 3 times -4 is -12y. And 9 times -4 is -36. Okay. So the first term gets eliminated. They're equal and opposite. The second ones, I add them up and I get -17y. And the next one I add up and it looks like I get -17. So I'm going to divide by -17, divide by -17, and y equals 1. All right, so if y is 1, I'm going to put that in my y spot. And I need to find what x is. I'm going to plug that 1 in here. Okay, so I've got, start up above, hopefully I don't run into it, 2x plus 3 times 1, which is just 3, equals 9. Two-step equation, subtract 3, 2x equals 6, divide by 2, and x equals 3. Okay, so my answer is 3, 1. Now, of course, these get slightly more complicated if they are, like I said before, numbers that don't multiply to be each other. You just have to do like I did when I took the 3 and the 5 and multiplied them. You can always multiply them times each other. If they're really large, though, you'd want to avoid that. So think about least common multiple. All right, other thing I promised to talk about was what happens, how do you get an answer like no solution or infinite solutions? Because these are going to still graph out to be the same 3 options as our graphing equation. So we still could have 2 parallel lines, and that would be a no solution. But what does that look like in your answer? Well, that's an answer that doesn't make sense. Like 0 equals -4. Well, 0 doesn't equal -4. Those are not equal to each other, and therefore it's not true and there's no solution. 3 does not equal 2, for example. So if 3 doesn't equal 2 and that's the answer you got, then that's no solution. Okay? Other times you'll get other equally confusing answers like 5 equals 5. That doesn't really say x equals something or y equals something. Or x does equal something, x equals x. Again, what if x was 2? Well, then 2 equals 2. What if x was 7? Then 7 equals 7. Those are going to be where we have one line like this, and the other line would be directly on top of it. Okay, so that would mean every single point on that line was a solution, and we call that infinite solutions. Okay, those are kind of the rare thing that happens. However, it does happen. In math, it seems to happen even more often. I hope this helped. Have a great day.